Okay, ready? Okay, now that we have all the bolts out of the triangle pieces, we took this side out and this side out. We're going to pull this off. Now there's more than likely going to be some fluid that comes out of here, which isn't a big deal. That's why I have these towels down here to capture the fluid. So when I pop this off gently, you'll see a little bit of old solution coming out of there. So this is what the end caps look like. You have the 3 chambers, your 3 check valves. Inside here you'll see, and this pump is a little over a year old, you can see that these check valves are actually in really pristine condition, and realistically this wouldn't need anything done to it. You can see that the tappets look good and the O-ring is solid. There's no discernible wear anywhere on here. The spring's in really good shape. Everything is really solid. When we look at and this is the high pressure side of the pump, so this is under load. We want to check the plastic for any signs of degradation. It's still really solid. I can rub my finger across it. It doesn't disintegrate under my hands. I can scratch it with my fingernail. And from what I can tell, there's really no discernible signs of damage to the ends. And this is through a whole season of running bleach concentration through this pump. So after we take the end caps off, we can remove the check valves. Now what will happen sometimes, and this is normal, the check valves will come apart from the O-ring like that, and high pressure pumps will do the exact same thing. Here's how the check valve goes together. You have your seat, your tappet. This is called the tappet, and again, if you look at the tappet, there's really no wear or damage to it at all. You have your spring, which is still looks like brand new. You see there's no rust on it. And then you have your cage, and what will happen is the cage will lock into the check valve like that, and then the O-ring goes over the outside. When you put these back together, the directional flow is always through the tappet into the pump. So the other side will be set in here just like this. So after we pull those off, we can take the inlet side off. Same thing. We can pull one of these check valves out of here, and sometimes you need a reverse grip pliers to do that, but I'm going to do it an easy way. So we have the ends off. Now we can take the head off with the right size socket. We can take the heads off, and you can see what the diaphragm looks like. Now you'll notice we didn't drain the oil out of this pump, and we did that on purpose because you don't have to. So we take the head off. Sometimes you might need to pry it. There we go. I just used the rubber end of a pliers to get that off. There we go. And that's what the inside of the pump looks like. This is your diaphragm on here, and you can actually see the oil on the other side of it. But your diaphragm will be seated in there, and you see what happens is there's a bolt that runs right through the center. I'm going to soak up the fluid so I don't have to worry about any contamination. Typically when these diaphragms fail is where they'll fail is right around the edge here, where all the movement of the diaphragm goes up and down. And you see the diaphragm's very flexible still. Here you see the inlet check valve, and when I pull the head off, it's very easy for me to pop out. The inlet and the outlet are 2 different sizes. You can see if I get this reversed, I can't get the check valve in, but the inlet is larger so that I can push the check valve into position. Again, we'll look at this check valve here. There's really no sign of wear to the tappet. The springs are in really good shape. They're solid. They're not brittle. There's really no rust other than some surface rust on here, which is typical. You'll see that in a pressure pump. And that can be more related to water quality than anything else, because if it was bleach, the whole thing, if the bleach was damaging it, the whole thing would be damaged. So you can see there's really no signs of wear to these check valves. So after we get the heads off, we got to take off the diaphragm. We just loosen up this center bolt. We pull the piece off of here. I got a little more fluid in there I want to soak up. Okay. Now if we look at this, you can see that the diaphragm itself, and typically, again, where they wear is right on the seam here. That's where if you have a failure, it'll typically be right on that seam. But you can see this is still very flexible. It's not brittle. I can rub my finger on it, which you can't see in a video, but there's no, it's not brittle at all. It's actually still very soft and supple, which is really really good. So we're gonna use this rag and clean up that little bit of oil that's on there, so you can kind of see what the inside of this pump looks like. And we don't have to drain all the oil out because the way these seals are designed, they actually won't drain out. But you can see there's no rust, no contamination, no problems with any of that. So it's really in very good shape. Now, when we put a new seal in, you'll see here's the old one, here's the new one. The discoloration is from the dye that's actually in the oil. This is what they look like new and used. So you can see how it's been, from the motion of going up and down, how it's kind of changed the shape, but again, it's still very soft. When we put this in, and if you look at it, there's an upside down on the right side. When you read it, if you can see that, it says udor right across the top there. That will always be facing out. So that will just sit right into the groove. Okay, we're going to take the spacer guide and the bolt. You could put some Loctite on here. They have some blue Loctite. And what we'll do next step is we will put this in here and tighten it down. You want to give me some Loctite?